Now we are going to look at a unique situation that is not exactly defined by an equation, but nevertheless we will create a conversion factor out of it at some point. And that has to do with the relationship of the variables related to a gas at something called STP. What is STP? STP stands for standard temperature and pressure. In science, especially chemistry, standard temperature is 0 degrees Celsius. Remember that many times some scientists may just say that the temperature is standard temperature. Well, that's 0 degrees Celsius. In Kelvin, that's 273 Kelvin. There is another temperature in science called room temperature, and it's not the temperature of just about any room you are in. Room temperature is 25 degrees Celsius or 298 Kelvin. So remember those two facts: standard temperature and room temperature. So at standard temperature of 0 degrees and standard pressure, which is defined as 1 atmosphere, it turns out that any gas has a molar volume of 22.4 liters, meaning 1 mole of any gas at standard temperature and pressure occupies 22.4 liters. What does that mean? Well, we already said that there are four variables we will look at as it concerns gases. That's temperature, pressure, volume, and number of moles. And that's what we are doing here. We are saying that temperature is 273 Kelvin, pressure is 1 atmosphere, number of moles equals 1 mole, and it turns out that volume will always equal to 22.4 liters as long as temperature is 273 Kelvin, pressure is 1 atmosphere, and number of moles of gas equals 1. So this is a very big revelation. Think of it this way: if you go and buy a tiny refrigerator, a freezer for your bedroom to eat snacks out of at night, and it turns out that the temperature you set it is 0 degrees Celsius. Turns out it has a volume of exactly 22.4 liters. And since we are mostly living at sea level, pressure is 1 atmosphere. Then it turns out that the number of moles of all the gases inside will equal to 1 mole. That's what it means. You don't have to sit down and count. You can never count the Avogadro's number, which is 1 mole, 6.022 times 10 to the 23. But you can rest assured, according to the STP fact, that at STP 1 mole is what will equal to what 1 mole of a gas will occupy 22.4 liters. So here is a problem. Calculate the density of 4 grams of helium at STP. It might seem unrelated, but it's not. We are trying to find the density. Density equals mass over volume. We are already given the mass, which is 4 grams. What is going to be the volume? Well, volume will be 22.4 liters. So the density of helium at STP will be 0.178 grams per liter. Okay, so we know what to expect as to the density of helium.